Hello, I'm joined now by Professor Deborah Greaves from Plymouth University. Welcome to the broadcast, Professor. May I call you Deborah?
Yes, thank you very much.
Deborah, what is the interest in your university in wave power or ocean power?
Well, we have quite a large research programme in marine renewable energy at Plymouth University. We've recently invested in some very large new facilities for testing of wave energy and tidal devices. A new wave tank, which is a unique or a novel type of wave tank which has directional wave generation as well as currents that can be generated in two directions.
How big are these tanks?
The largest one, the ocean basin, is 35 metres long, 15.5 metres wide, and operates at a maximum depth of 3 metres. So it really meets the intermediate scale testing of wave energy devices. It has a raisable floor, so it can operate at any depth up to 3 metres. And then we also have a coastal basin which can be used for sediment and coastal engineering studies, which has waves and tides and current generation as well, can be used for array studies and interaction with the coastline. But really the large ocean basin is the one that can be used for testing of structures, wave energy structures, and also in combination with currents.
There seems to be an interest in wave and tidal power in the UK, just at a time when there's a decreasing emphasis on wind power and some other renewables. Is this the new favourite?
Well, I think there's still a lot of investment going into wind, and particularly offshore wind, as we move into deeper water and further offshore sites for wind energy. And of course the new facilities that we've built are also going to be very useful for designing of the structures, floating structures for offshore wind turbines.
Are you just looking at the hydraulics, or do you also look at corrosion, the old bugaboo of the ocean?
Yes, well, we do have quite a bit of materials and structures research as well. But our speciality, I suppose, is in hydrodynamics and in coastal engineering, ocean engineering, and also environmental impact. So we have a lot of research looking at the environmental impact or the environmental effects, potential impacts of wave energy, tidal stream energy, and offshore wind.
Are there any known impacts at this point? Are there serious dislocation of fish patterns, that kind of thing?
Nothing negative has been shown so far. It's all being investigated. Obviously, we're at a very early stage for the wave energy industry, so we don't really have the large deployments in order to be able to get the evidence, strong evidence for the larger scale deployments. But we are learning from the smaller scale work.
This research facility at Plymouth University, is it available globally, or is it just for British companies?
No, it's available globally. We're very interested in using it for the marine renewable energy globally. We're very keen to do research and commercial work.
Deborah, give me an example of the kind of installation that you will test, the kind of thing that is going to be brought to you, and what you will learn.
Okay. Well, we've had a few people who've come and brought their prototype models of wave energy devices, and so we can test them in the wave tank, in regular waves, in irregular waves, in directional sea states. And also we can include obviously with the mooring arrangement, we can look at the loading on the mooring in combined current and wave loading. We have some research projects that have been funded recently, one of which is to look at the extreme wave loading on wave energy devices, so the extremes, breaking waves and focused wave groups, trying to understand the extreme loading that can be experienced by the device and affect its performance, and also by the on the mooring and its likelihood of staying in place. And we have other research funding to look at a new concept for a wave energy device, looking at the use of fabric, flexible fabric structures in wave energy. And also other projects which again are looking at extreme loading on the structures, not just wave energy structures, but other structures at sea.
It's very exciting, isn't it? Because there's no leader everything is possible.
It's all open.
It's one of those wonderful times where nobody knows what the technology that will ultimately lead the field is.
That's right. So there are a huge number of designs, completely different approaches to converting the wave energy to electricity. But still, as you say, we don't really know whether we've seen the winning technology yet, or whether there'll be a new design innovation which will change the way things behave and the way things move forward. So it's a very exciting field to be in.
What got you into engineering?
Well, that's. I originally trained as a civil engineer, so I did a civil engineering degree to start with because I enjoyed engineering subjects and I liked the idea of working outside and building things that would be useful and last for a long time. But I've always lived by the sea, and I've always been interested in the sea and waves and so on. So when I did my DPhil at Oxford University, that was in ocean engineering, really for offshore structures, fluid structure interactions and so on. And then from there I got more and more interested in wave modelling and wave structure interaction, and that led to wave energy particularly, and you know, it's a fantastic, very exciting field to be in.
Thank you very much. Very interesting, and good luck to you.
Thank you very much.